Hello everyone, my name is Christian Kaisi Siviri. In this video, I'll be working on Lab 1, Week 2 of the computer programming class. First of all, I'm going to read the instructions of what we'll be doing. Then I'm gonna show the simulation of it. Then I'm gonna build the actual and physical product of what we are doing. So let's read the instruction first. All right, so let's read the instruction, right? This lab is to provide an introduction to programming and to Arduino Uno. The task is to set up an LED circuit, right? So we're gonna build the LED circuit with a microcontroller. That means for microcontroller, we're gonna need we have an Arduino R3. Turn on the LED for 5 times, right? So the circuit has to turn the LED turn the LED on for 5 seconds, right? For 5 seconds, then blink the LED 5 times. So what are we gonna need? So we're gonna need a breadboard, power supply, one LED of 5 mm, resistor specified by the student. So for the resistor, we're gonna need to do some Ohm's law, and we're gonna see how many ohms we need, ohms resistor we need. Okay? So first we're gonna simulate that. We're gonna simulate a circuit in Tinkercad, right? Which we're going to do right now. So we know that we have 5 volts, and we also know 5 volts from the Arduino, right? Arduino, and we don't know the current that we need, but the maximum current that we need, and once we have the current, then we'll be able to calculate the resistance. So let's do some research. And I'm gonna do some research. LED 5 millimeter. That. So we have a lot of results here. So let me see where we are. So we are not shopping. So probably still just gonna be way at the bottom. Yeah, so we might get here. Let's see what we can get here. Equal to 20 ohms, right? 20 ohms, and we know our voltage equal to 5 volts, right? 5 volts. Now our resistance is what we need, right? Is what we need. So according to Ohm's law, so Ohm's law is volt equal current multiplied by resistance, right? So that's bringing us to find the resistance. It's going to be volt divided by current, right? Which is going to be 20, which resistance is going to be 5 divided by, so 5 volts, right? Divided by 0.002 ampere, right? So you have 5 volts divided by 0.002 ampere. So 0.02 ampere is equivalent. So so we convert the milliamps to ampere, right? To ampere. Yeah. So now we're gonna use our calculator to figure the value out. So we're gonna have 5 divided by 0.02, which is gonna give us 250. So our resistance is going to be 250 ampere. No, 200. So our resistance is going to be 250 ohms. So now that we know our three values, so our voltage is 5 volts. Our current is 0.02 ampere and volts, and resistance is 250 ohms. This is what we need. This is what we actually need. So this is what we need. And let's see the document. So the data sheet to find the current. So we have a forward current is 20 milliamps. So 20 milliamps. Then that's our current. Now that we know how much resistance we need, now we're gonna go ahead and design our circuit. All right. So let's build our circuit first. Then we're gonna see. So we are going to draw it. So we have our power source, right, which we're gonna change the value to 5 volts. Name is volt, and we're gonna change our value to 5 volts. And then we need our resistance. Our resistance and our resistance, then another resistance. So we're gonna connect all of them. So we have our resistance in circuit. Okay, that's done. And we're gonna need our LED. There, and that is gonna go here. Then we have our power source. So this is going to be connected now we got our LED right there. So this is what we are going to do. So this is what we are going to do. All right. So this is our circuit. So we design our circuit. We know that the first one is going to be, the value is going to be 220. So we have finished designing our circuit, drawing our circuit. Now we are going to simulate that circuit in Tinkercad. So let's do it. So what we need our breadboard. We need the breadboard, and we need the Arduino. We need 4 resistors. There are 4 resistors. 2, 3, 4, and we need the LED, right? So we have our first resistor is 250, 200, 200 and 210, 220. So our first resistor is 220 ohms, and the second one is 10 ohms. The third one also is 10, should be 10 ohms, and the fourth one is 10 ohms as well. So we have 220 ohm resistor, 10 ohms resistor, 10 ohms resistor, 10 ohm resistor, all 4. Then we have our LED. Okay. So now we need to start connecting our board to. We need our power source. So power source, we have 5 volts here. We have the ground here. So instead of connecting, we can get 5 volts. So here we're gonna have 5 volts on this pin. So we have to connect our board from pin 13 and to get our 5 volts, and then the other pin, the negative pin, the ground pin, we're gonna connect it to the ground. Yeah, so we're gonna do that. So I'm going to connect this pin to the ground, and I'm gonna use a black color for that. Then I'm gonna use pin 13 to a positive port, and we're gonna use the red color for that. I use the red color. Okay. Now we're gonna connect this to that. Create a connection. Then we're gonna put our first resistor. Okay. Then the second one resistor. Then we're gonna connect the second resistor. Then our third resistor. Then fourth resistor. Same time I'm creating connection right there. Then we're gonna put our LED. So we're gonna flip it so we have positive connected to that, and then we're gonna connect that to, okay, let me rotate it so we can have a clear view of what is going on. Yeah, then we can connect that to that, and this is gonna be you can see our circuit is complete. Now we finished building our circuit, and let's test it and see if it works. Yeah, we can see the light is on. Yeah. The light here is on. The light is on and it's blinking. And this is working already because I already have the code that I wrote previously. But I'm gonna do it separately so that it can be more clear of what I did to make it blink like this by following the instructions of the lab. Okay, so yep. So this is done. So this is the code. No, that one. Yeah. Now that we we did our simulation, now we are going to build it in physical so we can see as to build. So here we have our breadboard. Here's our Arduino. Here's a jumper wire, the red jumper wire there, and here is our black jumper wire. Here is our LED there. And here are our 4 resistors. So this is a 10 ohm resistor. This also is a 10 ohm resistor, and this also is a 10 ohm resistor, and we have 220 ohm resistor. Right? Now let's put it together. So first, I'm going to connect the Arduino to the breadboard. So we're gonna use a positive jump wire right here. So we're gonna connect this our jump wire to pin 13. Pin 13 right here. Pin 13, you can see, and I'm gonna connect it to the positive on the board, and we're gonna have the negative, the black jump wire, and we're gonna connect it to the ground. Connect it to the ground. And connect it to the negative. Since that one is since the one is done, now we're gonna connect the positive. As you can see, positive there to this row here, to this row, as you can see. So we have a positive circuit here, and then it goes right in this row. Then we're gonna have our first resistor, which is 220 ohms. I'm gonna connect it from here to here. That's our first one. Then we're gonna use a jumper cable to connect this to the next row. And we're gonna use our 10 ohms resistor. And we're gonna connect it to the next row. Then we're gonna use our jump wire as well. So all of these, we are connecting them in series. Then we're gonna have our ohm resistor again, and we're gonna connect it to the next row. And then we're gonna use our jump wire. And we're gonna use our resistor, the last resistor. Connect the last resistor there. Okay. Then the last then we're gonna connect our LED. Going to connect my LED, so we're gonna have the positive branch. So we have the positive and the negative, and the positive is the longer one. So I'm going to put it here. Always connected. Sorry that you cannot see anything, but it's right there. Okay, so we're gonna put it a little bit back. So we have pin open. Great. Make sure that these two does not connect. You can just move this one a little bit up there. Have a kind of space between these two. Right. Then we're gonna have I'm gonna need another. So I'm just gonna grab another cable, another jump wire. This time and this one. There we go. Yeah, so we're gonna connect the last one. So we're gonna use this black cable, black jump wire to connect to the ground, LED to the ground. And our circuit is complete. Now we're gonna test it to see how it works or not. So our simulation told us that it's gonna work. So let's see. So I'm going to connect my Arduino there and next. Here we go. Now it works. As you can see, the light is on. Okay, now we have completed our circuit, so we viewed it, and now we can see our light is on. The light is on, you see? Now, the only thing that we need is to make it blink. So let's do it. I open my Arduino. Now it's time to write the code. So as you can see, I already declared the variables. So the first variable is LED, which refers to the pin, which is pin 13, the one that we connect with the red wire. And it's going to turn, so the light will be on for 5 seconds, and start to blink for every 1 second. Okay, so now here we set up the LED to pin 13. Okay, now let's start putting the code. So first of all, I'm going to let's go and start the code. So we're gonna digital white LED. We're gonna put it to high. This is gonna take the LED to high to give it power. Then we're gonna delay on for 5 seconds. Then for 5 seconds. So that's what it says. On the light on for 5 seconds. Right? Then we're gonna put the condition, right? To blink. So we're gonna first you need to go off, then start blinking. Right? So we're gonna have a digital white LED. So to turn the LED off, we're gonna go low. Need a low value. We need the pin. We need to lock that voltage from going to pin 15. Okay. Then we're gonna delay for 1 second. Then we're gonna have like one. Then we're gonna you know, use more again. Right, then right, then we're gonna delay, and it's gonna stay on for 1 second. Yeah, for 1 second, and then we're gonna move forward. Then delay 5 seconds, 1 second. So this is already removed. Okay. So this is what is going to make it blink. This is a blink, first blink. So we're gonna come in. Maybe put some comment. Let's think for 1 second. Wait a second. Then we're gonna put this is a loop that is going to allow you to repeat this block of code, uh, 5 times. Okay? We're gonna count equal to 5. Then we're gonna count is going to implement not okay. Let 1 each time. And I'll put in the block. Okay. Now our code symbol will be complete. Now let's see if it actually works. I'm gonna upload it. I'll verify. And we have a few mistakes there. Then we're gonna check it again. Oh yeah, so forget value. That's what I'm looking for. Value of output. So this to output. Okay. Turn off some error. Okay. See if we can issue. I don't see any issue now. Yeah, so we're gonna upload it. Okay, now it's good. Now our question is good. Now let's load it. Okay, 1 second. 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 1 sec Okay, now our code is complete, and let's load it and see if it works. Yeah, and take a look at our circuit and see if the light is going to blink 4 times. One. Okay. Okay, let's see now. Let's initial 1, 2, 3, 4, 5, then go back to normal. So it's a normal 1, 2, 3, 4, 5, 6. So now there's a few things that I'm gonna fix first. Okay, now let's see if it works. 1, 2, 3, 4, 5. Go back to the first step. Nice. It works. Yeah, so that was the project. We did it, and let's submit our work now.